Welcome to this explainer. Okay, let's dive right into this. Today, we're tackling one of the most urgent and frankly, kind of confusing topics for enterprise decision makers and developers out there: large language model API costs. As organizations are rapidly adopting AI, figuring out the actual pricing behind these models has become absolutely critical if you want to build sustainable products.
And that brings us to what is literally the million-dollar question. Are you underestimating your AI deployment costs? Because so many companies are facing massive sticker shock when they roll out generative AI. And the reason? Well, they're trying to apply old-school software budgeting to a brand new paradigm. They completely misunderstand the ongoing consumption-based costs of AI. But don't worry, by the end of this explainer, you're going to understand exactly how LLM API pricing works, what drives those costs, and how you can make really informed decisions before you integrate AI into your products.
Here's our quick roadmap for today. First, we'll cover the mechanics of LLM pricing. Then, we'll get into understanding tokens and costs, followed by estimating those costs. After that, we'll compare the top AI providers, run through some killer strategies for cost optimization, and finally, help you choose your ideal API.
All right, Section 1, the mechanics of LLM pricing.
Okay, so to truly understand your AI budget, we basically have to throw out the entire traditional software licensing model. You're not buying a fixed price seat or a perpetual license anymore. It just doesn't work like that. You're paying for consumption, and that consumption is built entirely around this one core concept, the token. See, models don't read words or characters the way you and I do. They use tokenizers to break text apart into smaller chunks. These tokens are the fundamental atomic units that all LLM processing and, more importantly, your billing are based on. Essentially, more tokens mean more processing power, more memory, and more time.
So, what does that actually look like in practice? Well, here's a pretty practical rule of thumb for you. 1,000 tokens is roughly equal to 750 words in English. Or, another way to look at it is 1 token is about 4 characters of English text. But definitely be warned here. Different providers use different tokenizers, and non-English languages, complex grammar, and especially code are going to consume significantly more tokens per word, and that can drastically inflate your bill if you aren't prepared for it.
Moving right along to Section 2, understanding tokens and costs. To understand exactly how costs pile up from the very second a user hits send on a prompt, providers distinguish between 2 different types of tokens. On one side, we've got input tokens, which you might hear called prompt tokens. This is the text you're sending to the model, your instructions, the chat history, your reference documents. These are generally a lot cheaper. But on the other side, we have output tokens, or completion tokens. These are heavily priced, typically costing anywhere from 2 to 5 times more than input tokens. Why the big markup? Because the model actually has to do the heavy lifting of generating new text, predicting each token one after the other, and calculating probabilities across its entire vocabulary.
But here's where the landscape gets even trickier. Modern reasoning models, like OpenAI's O3 or Claude with its extended thinking capabilities, introduce what are called thinking tokens. This represents the internal reasoning process the model is doing before it ever gives you an answer. So, the really crucial thing to remember here is that a super short user query could generate thousands of internal reasoning tokens entirely behind the scenes. This can create massive, completely unpredictable cost multipliers of 10 to 30 times for complex tasks. It's a huge deal.
So how do we fight back against these rising costs? Well, one immediate way is to grab a massive 50% discount. Yeah, most providers will actually offer you this huge cost reduction on both input and output tokens if you simply switch from standard real-time API calls to asynchronous batch processing. If you've got non-urgent, large-scale workflows, say processing a mountain of documents overnight, batch processing is an absolute budget saver. And you can achieve an even bigger saving. We're talking up to a 90% cost reduction on input tokens by using prompt caching. Think about it. If you're constantly sending the exact same massive reference document to a model, prompt caching saves the model's computed understanding of that static text. So any subsequent requests just pull from that stored understanding, and it ends up costing you a fraction of the standard price.
Okay, Section 3, estimating LLM API costs.
So how do we actually estimate these costs before we deploy an application to thousands of users? Let's look at some real-world math using a legal tech example from our source material. Imagine you have a pipeline processing 1,000 contracts every single month. Each document is 10,000 input tokens, and the model gives you a 500 token summary output. Now, if you use standard processing with a model like Claude Sonnet 4.5, that would run you about $30 for inputs and $7.50 for outputs, totaling $37.50 a month. But If you apply that batch processing discount we were just talking about, that monthly cost immediately drops to $18.75. And if you use cache system instructions on top of that, you shrink that bill even further. It just goes to show how your application design directly impacts your bottom line.
Which brings us to Section 4, comparing top AI providers. Because honestly, understanding the math is only half the battle, right? You also have to pick the right vendor, and making that choice in 2025 is all about balancing pricing with very specific capabilities. Looking at how the major industry players are positioned based on the data, OpenAI is really noted for multimodal capabilities and seamless ecosystem integration. Anthropic's Claude, on the other hand, is recognized for safety, handling massive long contexts, and coding. Google's Gemini naturally excels in Google Cloud integration and search grounding. And then you have xAI's Grok, which is optimized for real-time information and integrating directly with the X platform. The big takeaway here, don't just stare at the price tag. You need to match the provider's specific strengths directly to your unique business requirements.
All right, let's jump into Section 5, Strategies for Cost Optimization.
Whether you are a CTO, an architect, or a developer, you need real, actionable ways to keep your chosen provider's costs under control. So here is your ultimate cost optimization checklist. Number 1, route tasks intelligently. Not every single task needs a massive flagship model. Use smaller, cheaper models for simple stuff like routing or classification. Number 2, optimize your prompt length. Just trim the verbosity wherever you can. Number 3, actively control your output length by setting max token limits or just asking the model for concise bullet points. Because remember, outputs are where you bleed money the fastest. And finally, like we discussed, leverage caching aggressively and schedule batch processing for all that non-urgent work.
Now, beyond just the tools the vendors hand you, there is an incredibly powerful application-level strategy you should know about, and that's semantic caching. If your users are constantly asking the same frequently asked questions, you can actually use embedding similarity to find and reuse those exact answers. You're simply retrieving the stored output from a cache without ever having to make another expensive API call to the LLM. It's brilliant.
And finally, Section 6, choosing your ideal API.
So how do you actually formulate a long-term, scalable procurement strategy? Well, first you have to realize that the per-token pricing we've been talking about is really just the tip of the iceberg. Your true total cost of ownership is defined by operational factors. Think about it. How much developer time does the integration actually take? What are the rate limits and throttling policies going to look like during peak traffic? What is the actual output quality for your very specific use cases? You absolutely have to evaluate things like SLAs, latency, and debugging tools because all of those directly influence the real cost of your development and maintenance.
To mitigate risk and keep those costs optimized, the source data strongly advises building out a multi-provider strategy. Basically, use the cheapest adequate model for any given task. Always maintain fallback providers so you have guaranteed redundancy and uptime. Route specific tasks to the vendors that excel at them. And critically, use abstraction layers in your code. This simplifies managing multiple APIs and keeps you from ever falling into the trap of vendor lock-in.
As we look forward, there's actually a very optimistic trend for businesses. Thanks to massive hardware efficiencies, specialized AI chips, and some intense open-source competition, industry analysts expect API costs to drop by roughly 20 to 30% annually. But because this landscape evolves so incredibly fast, with new models and those tricky reasoning token economics, constantly benchmarking your systems is going to be absolutely essential.
I want to leave you with this final, somewhat provocative thought. Look, it's pretty easy to hook up a powerful LLM and build a flashy demo. But are you building just for raw AI capability? Or are you actually building for sustainable, cost-effective scalability? Because by mastering token economics, caching, batching, and intelligent routing, you can build AI products that deliver massive enterprise value without completely destroying your budget. Thanks so much for joining me for this explainer.